Hello friends, this is Bindu Kumar here. Let's solve this question together. An arithmetic progression consists of 50 terms, of which third term is 12 and the last term is 106. Find the 29th term. So what is given in the question is, there is an arithmetic progression which has a total of 50 terms, in which the third term is 12 and the last term is 106. We have to find what is the 29th term. So let's write down what we can understand from this question. The first thing that we see is the number of terms, which is the value of n. Right? There are total of 50 terms in this arithmetic progression, of which the third term represented by A3 is 12 and the last term is 106. Now what is the last term here? It is already given that n equal to 50, meaning there are 50 terms. So we can write A of 50 equals 106. Now we have to find out the value of 29th term. Right? So this is what needs to be found out. Now how do we define an arithmetic progression? So a set of numbers A1, A2, A3 are said to be in arithmetic progression if they are of the form A plus D, A plus 2D and so on, where D is the common difference and D can be calculated as A of n plus 1 minus A of n. For example, D equals A3 minus A2 and D should also be equal to A2 minus A1. There is another formula for which is used for finding the nth term, which is A of n. So A of n equals A plus n minus 1 into D. Now if you look at the question, they have given us the value of A3 and A50. So we can make use of the last formula here to come up with some equation. So let's write the equation for A of 3. So A of 3 equals A plus n minus 1 into D. Now here we know the value of A3 as 12 equals, we do not know the value of A, so we will write it as this, plus the value of n here is 3 minus 1 into D. We do not know the value of D, so we'll write it as this. So now 12 equals A plus 2D. Now what I want to do is I want to keep A on one side and remove everything else. So how can we do that? First I will write the equation as this, 12 equals A plus 2D. Since I want to remove the 2D, I will add a minus 2D. Now whatever I do on the right hand side of the equation should be repeated on the left hand side of the equation. So by doing this, we can see plus 2D and minus 2D cancel out each other. What we get is 12 minus 2D equals A, or we can also write A equals 12 minus 2D. Okay, so there is no way to simplify this further, so we will write our next equation based on the 50th term. So we have A of 50 equals A plus n minus 1 into D. The value of A of 50 is 106 equals A plus the value of n here is 50 minus 1 into D. 106 equals A plus 49D. Now there is no way to simplify this further. However, you can see we have A here and we have found the value of A to be 12 minus 2D. So let's substitute this value here and see what happens. So I'll write 106 equals 12 minus 2d plus 49d. 106 equals 12 minus 2d plus 49d after removing all the brackets. 106 equals 12 minus 2d and plus 49d will become plus 47d. Okay, now I want to keep d on one side and remove everything else. So how can we do that? So I'll write 106 equals 12 plus 47d. I want to remove the plus 12, so I'll add a minus 12, and whatever I do on the right hand side should be repeated on the left hand side as well, because we want to balance the equation. So plus 12 and minus 12 will cancel out each other. We have 106 minus 12, which is equal to 94. So we have 94 equals 47d. Now here again I want to remove 47. So we will divide both sides of the equation by 47 to balance the equation. So we have 47 divided by 47, which is equal to 1, and we have 94 divided by 47, which is equal to 2. So how did I get that? So you can multiply 47 into 2. So 2 into 7 equals 14, and 2 into 4 equals to 8. 8 plus 1 carry over, we get 9, which is the same as the numerator here. So finally we get the value of d equals 2. Now let's take this value and substitute in this equation. So we have a equals 12 minus 2 into the value of d is 2. A equals 12 minus 4, which is equals 8. So we have found the value of a, which is equal to 8. We have found the value of d, which is equal to 2. Now let's write the formula for a of 29, which is what we want to find out. So a of 29 equals a plus n minus 1 into d. A of 29 equals, the value of a we have found out as 8, plus the value of n here is 29 minus 1 into 2 equals 8 plus 28 into 2 equals 8 plus, so 28 into 2 is 8 into 2 16, plus 2 into 2 4, plus 1 5, we have 56. Okay, so 56 plus 8, we get a of 29 equals 64. So the value of the 29th term in this arithmetic progression is 64. Thanks for watching this video. Remember to like, subscribe, and click on the bell button to get notified of new videos.